Or sword? No. Last time you guys were getting the code in the Google Doc. It was like like copy paste. Why wasn't there a no not I tried to use the thing on I did on purpose. You sure that's on? It's on. Oh, it's because you're not selecting something like this. Oh, now try. All right, do. You have to make sure you select this or it actually works. Speedrun. And then it's 21. I will leave this. It shouldn't take too long. I don't really go too deep into the. How long will it take? How long will it take? Do you have a demo? It's literally I'm trying to do more discussion. Okay. Hopefully you guys more. And this works. Sweet. All right. Thanks for coming out today on I forgot. I don't know what today's second. It's the two like the specific date. Oh, week 5 Tuesdays. Thanks for coming out. On May 2nd. This time and from here on out to for the rest of the quarter, it's going to be a little bit different. Last week was purposefully computer vision, and so this week is a nice little bridge from computer vision and talking and getting into autonomous vehicles. And this time it's going to be, we're switching things up for the remainder of the quarter where we've covered all of our workshops and all of our code and pretty much for the entire year. So what I was going to send out to you guys last week, which this week I would love for you guys to fill out is for the entire year up to this point. If you guys have been with us, I'll be posting this in the Discord for some of our other members as well. Is if you guys could please fill out this feedback form on how we did just on like the collab notebooks, on our code, and what you guys want to see from us going forward. Especially if you want to be with us next year, what do you guys want to see when it comes to coding, when it comes to how we hold our workshops? Do you guys like the collab notebook system where you guys just fill in the blanks? Do you guys prefer just walking through the code and just giving like something similar to last week? Whatever your preferences are, do you guys just want a full code? Whatever it is, we want to hear from you guys. We're trying to make this the best experience possible for you guys. So all your feedback is just greatly appreciated. It makes us do better as well. So if you guys can fill that out on your own time whenever you want, that would be great. And yeah, without further ado, let's get into autonomous vehicles. So like I said, this is going to be a little bit different. It's going to be more of a discussion. It's going to be more of us really kind of seeing how these work, how and where we're headed, especially in this field. It's very new, and it's something that whenever you think about a self-driving car, I always think to the cartoons that I used to watch growing up, where you just hop in and you just tell it to go and it'll go, right? And you take your hand off the wheel. That's what I first think when I think of autonomous vehicles and autonomous driving. What about you guys? When you think of an autonomous vehicle, what is the first thing that comes to mind? Go for it. The trolley problem? I expected that one to come up. What specifically about it?
Do you prioritize the passenger or do you prioritize the pedestrian if you cannot stop it?
Exactly. So that is definitely something that comes to mind as well. How about the rest of you guys? Yeah. Right. Yeah.
Just the future of driving, how the efficiency might increase significantly if it's only self-driving,
right.
Like self-driving, yeah, and other people driving as well.
Right. Anyone else? So the one thing, oh, were you gonna say something else?
I was gonna ask, has anyone made a self-driving bus?
I don't think so, actually. I have not seen anything related to that. I mean, yeah, if you train technically, but it doesn't really count. But the one thing that slips a lot of people's mind, if you were driving, if you were put in the front seat of one of these cars, you're putting trust in the software and you're putting trust in the camera systems and whatever perception technology that they're using. The biggest thing that I think about when I think about the future of autonomous driving is safety, and how can moving forward, are the systems that we employ today safe? And if so, what are the techniques that are currently being used to ensure safety in the car? And secondly, going forward, is there anything else that we can be doing such that we can make it so that we can reach that level of autonomy where we can take our hands off the wheel and we can feel comfortable with it just driving ourselves? So before we really get into a proper discussion into how all of these works and where we're going, let's talk about the levels of autonomy and where we currently are. There's 6 levels of autonomy, from level 0 to level 5. Level 0 being I'm driving my car and I'm not getting any assistance whatsoever. Level 1 is you get some vehicular assistance. You know, I'm going to cap my speed at a certain limit. I'm going to get, and just basic monitoring of your vehicle. And it'll give you guys some metrics on where you guys are at. Level 2 is I can accelerate, I can steer. Level 3 to 5 is where we get into a lot more autonomy. And I'm going to ask you guys actually. So level 3 is more conditional, so environmental detection. So I can recognize my environment, right? Level 4 is almost full autonomy, but humans still have that feature of overriding, right? At any certain point, if I feel like it's going out of control, I can take control of the wheel and I can make that decision to stop it. And lastly, level 5 is full autonomy. I'm driving, my hands are off the wheel and I'm just going. All right. So based on this, and based on what you guys know already, what level do you think we currently are at? 4? Why?
Okay, our current in the sense that, okay, 4 is well, in the context of self-driving cars currently made, we're pretty much at 4, but in a day-to-day context, probably 3, because that's what most cars like I see these days have.
Right.
So we're somewhere in between that.
Okay. Anyone else?
Yeah, I'd say between 3 and 4 too. I think I saw this YouTube video of this dude trying a Tesla autopilot, just completely doing it on its own.
Right.
And it worked for the most part. So I think it ran into some columns on the highway or something. He had to take the wheel and maneuver that himself.
Right.
So for most of the time it did work, but there's obviously some situations where it didn't work.
Right.
So I would say yes, you can do that.
Okay. 5? Why?
They were like, oh yeah, you guys are out late at night, we have fully autonomous self-driving cars. We got to see them, there's no driver.
Yeah.
I feel like it depends on the context,
Mm-hmm.
because in a testing environment, I'd say 5, no question. But in an environment where it's commercial sale,
Right.
and the company is willing to take full liabilities, I'd say probably 3 max.
Okay.
I was gonna say the same thing. I bet in testing conditions, some companies or when stars have level 6,
Right.
but maybe available mostly 3 or 4.
Right. All you guys are right to a certain extent, but the context does matter, right? In a testing environment, there have been cases where, we have reached full level autonomy, especially at USF's campus and other campuses across, and where you see different cars and they're just going. But that's a very limited environment. But when you look at a commercial environment and when you talk about companies being liable, Tesla is the one that's coming out and they're claiming level 3 autonomy. They are not at level 3 autonomy. They're at level 2 autonomy. So the max level of autonomy that we have reached currently in the commercial sale that you guys will be able to use in autopilot is level 2, not a level 3. And we'll get into more of why. And we're going to get into more of, if we're at level 2 right now, how do we get to the goal of reaching level 5 fully, where we can feel comfortable behind just sitting in the car and putting in some destination, we just go. All right. So here's where I'm going to harken back to what we talked about last week. If you guys were here, if not, I'll answer this question anyway. But what are the 2 fundamental components of an autonomous vehicle? What do you guys think that those 2 components are? Forget the actual vehicle, but like, what do you need for it to run?
With sensing and motorization.
Okay.
You take in the surroundings and give instructions to the, wheels.
Yeah. Pretty much you hit one of them. The second one is in the name. What does that mean? All right.
It's a vehicle?
No. What you guys got? The 2 things is the sensing or perception technology that is employed, and the second thing is the actual neural network models that are being used, right? So you can't have one without the other. They both work in harmony, especially if you remember what we talked about last week with computer vision. You need to be wary of the perception technology that you're using. When it comes to autonomous vehicles especially, you need to be wary of the perception technology that you're using such that you can design a model around it. All right. So yeah, perception technology goes hand in hand with neural networks, right? We want to be able to utilize the best possible out of the 3 we're going to cover today, the best possible perception technology, and we want to utilize and we want to be able to create the model that best works with the data that we have, right? And where we're getting it from. Right, so let's get into the 3 main kind of perception devices that are being used today. And then we're going to go into these and we're going to really look in depth into all of these, where we get into camera systems, LiDAR, and radar, right? Well, have you guys heard, I would say, have you guys heard of LiDAR and radar before? Sweet. So you guys already have pretty good start. And now the question that we want to ask is, out of these three are the most commonly used, right? Out of these 3, which one going forward is going to give us the best safety, the best chance of us surviving in the car if it gets to that point? And then from there, how do we take things going forward? What does the future look like? So what we're going to explore right now, where are we right now? We're going to talk about autopilot because you can't not talk about autopilot. We're going to talk about how autopilot works in this context. And then we're going to see how can it actually be made better, right? So firstly, cameras. Right now, and a lot of these autonomous vehicles that you see today with self-driving capabilities or in any other sense use a camera system, right? And it employs a fisheye lens. And if you take a look at these photographs, I want to ask you guys, why? Why would we use a fisheye lens camera?
The professional stretching and try to determine distance from that.
Not quite.
Maximize our Apple.
Exactly. That's the thing that we want to do the most is we want to be able to maximize your field of view. That's the biggest thing. If we have the biggest range, we'll be able to understand our environment better and we'll be able to make better predictions off of it. The question when it comes to depth and understanding that depth perception is something that we're going to get into pretty soon. But what is the ideal system, right, for an autonomous vehicle, especially today? It really depends on what kind of level of autonomy you want to get to and how far you're willing to take it, right? If you want maybe level 1 autonomy, at best, you need maybe a couple of cameras, right? If you want to ensure the most safety, you want to put a camera everywhere, right? But in this case, it's especially today when in Tesla's autopilot, they use 8, they use 4 at the front. I actually want to get your opinion on this, and I want to ask you guys why. They use 4 fisheye cameras at the front and 4 fisheye cameras at the back. Why? Why do you think?
Parallax.
What specifically about it?
Oh, what specifically about it? I mean, if you have 4 at the front, then like, I'm gonna assume that there's 2 at each corner of the car.
Mhm.
So you can measure like, because of the separation, there's going to be a slightly different distance from each camera, so you can use that to roughly estimate how far away it is. There's also like an element of error, specifically with this parallax, works don't get a super specific measure.
Mhm.
But just by having more spots to measure things from, you can triangulate.
Exactly. That's the biggest thing in with parallax. Yeah. Redundancy is a part of it, but it's not as big as parallax. Redundancy is important where you want to stitch together a proper field of view of your surroundings, but in the end, it's still not enough, right? So when it comes to cameras, how does it work, right? And this is where we are today. All right. So what we want to do is, like Kevin, I think you mentioned, right? This is curved and we might be able to get a better depth out of it, right? But really what we want to do is maximize the FOV, but it's still not the best image to gain information out of. So what are we going to do? We need to convert this into what's called like a stereo image, right? And a stereo image is like, if you just take a normal photo from your normal camera, that's a stereo image. What we need to do is we need to convert these like curved edges and these curved lines, and we need to straighten them, and we need to convert them into an image that our neural networks can actually understand. Right now, there's nothing really fully developed and fully like accurate such that you can just plug and play a fisheye image into a neural net and we're able to give you a proper answer, right? So first we're going to convert into a stereotype image, and then we're going to plug into whatever our model of choice, and then we can make a decision based off that, right? Okay, this is 200 meters ahead of me. I don't need to slow down right now. I can keep going until I reach this point, and then I can turn, right? That's the biggest thing, is we need to convert into a stereotype image, and then from there we can make better decisions on that. All right. So let's get into autopilot, because I think this is pretty interesting and something that I've always been kind of just fascinated about, is like, how does this really work? Do any of you guys have Teslas and actually have autopilot on it? Yeah, dope. I think it's one of the most fascinating things that has come out recently and has been a cause for a lot of debate when it comes to safety. And we're going to get into why some of this just don't work. So we already talked about systems where you have 4 cameras at the front, 4 cameras at the back. Each camera has its own function. One is for long range, one is for short range. What we want to do is we want to get the maximum FOV, right? And we want to be able to better understand our environment. At the end of the day, that's what it comes down to, right? And what Tesla's what they employ is something called monocular depth perception. All right. And for our sake, I'm not going to get too much into the weed of it, but if you have, I'll just read straight off it, but it's what it is you're getting the depth of an object based on the relative motion of something stationary. So if something's moving around and you see something stationary, you'd be able to get there's like a really good GIF of this I'll post. You get a better understanding of it. But Tesla's unsupervised Tesla's model is unsupervised. Just straight up, what is an unsupervised learning model? Yeah, exactly. So it takes in data as it comes, right? And that's the biggest thing, is how can you take image data that you're getting automatically, train it, and make a decision right off that, right? And here's pretty much how it works, right? If I have an image, I'll actually go back up here, right? And I think this is a pretty good example if we want to I'd say pretend these two are side by side, all right? That these happen within moments of one another, right? What is a video if not just multiple images stitched together, right? So if I want to measure the distance to this point here, and let's say over time, I need a better picture, but let's say I want to measure the distance from my car to this point, and I move forward in time, and the point is now somehow closer, right? We can still identify that point using, like if we use using a convolutional neural network, right? So firstly, we're gonna convert into a stereo. We're gonna identify the point, and we're gonna put it into a CNN. And then once we put it into a CNN, we can identify that, okay, that's the thing that we want to measure, and we can use, oh, I'm going backwards. We can use this formula here where all it's doing is it's a projection. We want to use, and it's a projection and it's a mapping, and what of a point between in time. All right, what we want to do is we want to identify a certain point t, a point at time t. We want to see a point at time t minus 1, and we want to see a point at t plus 1, right? Once you are able to identify that, we can get a somewhat accurate measurement of depth, right? And when it comes to FOV, this is the formula they try to employ. All it's saying is, let me just stitch together my source images and my target images. What am I trying to predict, and what am I going off of, right? Autopilot at its core, it's at least this is the maximum level of unsupervised learning within autonomous vehicles that we have right now. Tesla would like to tell you otherwise. They would like to tell you it's level 3, but there is a reason you are still liable when you crash. If you are in autopilot and you crash, the reason is that this formula right here is not very accurate. It is not the most accurate at all. It gives you about, at least from the research that I've done, it's about an 85% accuracy rate, which is high. What's up?
So it's only taking in, is it using one camera? Is it trying to estimate depth from one camera, or is it using parallax to estimate depth from all four?
It's going to estimate depth from all 4 cameras.
Why is it called monocular?
That's just the way they like to say it, but in reality, it's not. It wouldn't be the correct term, but it's more of a parallax system than it is a monocular one. But in this case, the reason that they call it a monocular system is because this formula over here is what is what you would use to. I would say like these formulas are used mainly when you're trying to use a monocular system rather than a parallax one. It's not the right term, but it's the math that they use kind of pushes you in that direction. Yeah, so what we want to do, I forgot where I was at. Yeah, gives you about an 85% accuracy rate, which is, it sounds great in theory, but would you trust your car 85% of the time? If you were to let go of the wheel, would you trust your car 85% of the time? I just want to, probably not, right? Definitely not. It's great to kind of think about where, although they might say like in the edge cases, that's where we get the problems, but that's where all the accidents happen. And that's where you have to trust your car to make the right decision. And right now it does not. And that is because of that formula over there, right? The projection mapping is not the most accurate. So is just using cameras safe? And we explored the math behind it. It's just not, right? The depth perception is not accurate as much as we want it to be. Just using cameras is not going to work. So knowing this, it's not like Tesla and other companies have not known this for a while. Why don't we migrate to LiDAR already? Why don't we go to radar already? How come we haven't done that yet? This is an open question.
Why Tesla use it?
Just in general, how come like majority of the systems today have not employed cameras? Inherently are not safe because depth perception has within just cameras and images is not the most accurate yet. So knowing if we know this, the companies that are making these vehicles definitely know this. How come we haven't done anything about it yet?
Guessing LiDAR and radar are more expensive.
Exactly. Oh, there we go. It is a money thing. It is not a safety thing. It's not a research thing. It is simply a money thing. No company wants to spend the amount to, especially research and development LiDAR and radar, and to just get for a safer vehicle. What they have realized is that, all right, my camera system works about, at least in a majority sense, it works most of the time. We're telling our customers we want you guys to be liable for it. So at the end of the day, if we can cut some costs here, then it's not really our issue to make things better if we know we already have a reliable system, right? So the question is, moving forward, right? Where am I at on time? 34. Excuse me. So the question is going forward, right? What do we want to do better? And that's where we get into LiDAR and radar. LiDAR and radar are some of the biggest up and coming, not up and coming, but they've been around. But the problem is, like you said, it's just too expensive. But obviously, as we advance and we keep going forward, these technologies are going to be more and more accessible. They're going to be more and more available for these companies to use, and for just in research purposes in general, right? So how do these work? How do we employ them, especially in the sense of autonomous driving and autonomous vehicles? And how can we, and what are its limitations? How come, like, if it was so cheap right now, would we use it? The answer is still no, we would not, because the camera system still is going to be more safe, right? So LiDAR in the basics, what's up?
Did Uber use LiDAR?
I'm actually not sure. Did they?
Because I remember they used either cameras or LiDAR, and I think that's what caused the whole accident.
Oh, that's right.
They did?
The accident.
What's the accident?
Oh,
I'm not informed on this.
Self-driving car ran into a person and killed them.
Oh wow!
Bike, I think.
And that was using LiDAR.
I don't remember. Let me do this.
All right, yeah. Let me know on that. That is really interesting. We're going to get into the limitations of LiDAR, so we can actually explore why that happened. Actually, yeah. Speaking of limitations of the cameras and the amount of accidents that you hear about autopilot and running into like a barrier you didn't even know was there, running into people, or just freak accidents on the road. The reason is it doesn't understand. In the 15% of the time that this fails, that's what happens. It incorrectly measures the depth and it goes full speed ahead right into whatever object. And if it wasn't there, it would have continued going. That is the biggest worry with autopilot. If you are going to use it, keep your hands on the wheel and be alert. At any point, you won't know when this thing might fail and you're going to be put in a really bad situation. And so get into LiDAR, right? The first thing is just some background on it. It's first used by the NOAA to map the ocean floor. And the biggest thing about the reason why that's so important is that means it can work in the dark. And then one of the biggest limitations with cameras is that it really doesn't work in the dark. If I don't know my surroundings, then how can I make a decision off of it? If I'm just taking a picture, I mean, even normally, if you guys take your phone out and take a picture in the dark, you guys don't really see anything. You get something very, very blurry, something very, very foggy, right? How can you make accurate decisions on that? You just can't. So that's where we can use LiDAR. We can use it in much better conditions. We can use it in a lot more different areas, and it's safer. What cameras are doing is it's giving us, what we need to do is we need to give a 3D metric on a 2D image. That is really hard to do, and as the math is not very accurate, right? So if we can just build a 3D environment, then sweet, and that's what we can do with LiDAR, right? But what are its biggest issues? And especially, was it LiDAR?
Yeah.
And it just straight up missed.
Yeah, just missed the.
All right, so especially LiDAR is prone to fail mainly in foggy or just like really heavy, intense weather conditions, where it will create an object that doesn't exist, and it will either slow down or speed up. It won't see an object or an obstacle in the way, because of the time it takes for it to measure and to get that depth metric. It's a big problem. So what's the workaround to this, right? LiDAR has many issues, especially in these conditions. I can create objects, it can take away objects. It's not the most safe. So what can we do? Well, research is being done to adjust the actual wavelength of the light beam that's being used for LiDAR, and adjusting the wavelength. So if we can actually increase the wavelength of the light, maybe it won't be as prone to some of these issues as before. But that's still very theoretical. It's still very elementary. Going forward, let's keep an eye on where this goes, right? So how does it work, right? What we want to do is we want to shoot a light beam from the LiDAR sensor just straight out. And the second it hits a certain object, we can measure the distance. And what does that do for us? It gives us a 3D map, right, of our surroundings, which is huge, right? It's something that, okay, we can understand not only our surroundings better, it's more precise. It gives us those metrics that we can then plug into our neural networks, and it's more accurate that way, right? Our car is able to make better decisions, and our car is able to properly and you feel safer in the car, right? But now, based on the limitations, based on the research, this is just an open-ended question. I just want to get your take on it. Would a car system of just LiDAR, our cameras, be safer than what we have now? I just want to get your take.
The ensemble them probably.
Okay.
But
Elaborate.
Like if we sort of use them together and use like a weighted evaluation of when to use LiDAR and when to use a camera.
Okay.
Yeah.
I mean, when the camera systems have the same issues as LiDAR in like cloudy, or not cloudy, foggy conditions.
They have the same. That's the thing with the cameras is the limitations to LiDAR are very specific to the weather. The problem with the cameras is that it's weather centric. It's and it's like time centric too, right?
Cloudy situation.
Right. Yeah.
Like, I don't know what they had problems in their test track because it's cloudy,
Right.
and they couldn't tell where the edge of the road is.
Right.
Similar problem.
Exactly. It's so currently in its current state, if you were just to use a LiDAR system, you're gonna end up with the same problem. That's what I wanted to get to, is you're gonna end up with the same problems that you have right now. With all of its limitations, sure, there's work being done to alleviate that, but right now, if you're just to use a LiDAR system, you're gonna end up with the exact same situation that we are in right now, which is at a level 2 autonomy for commercial use. And going forward, you still won't feel that safe in the car. So what else do we have at our disposal? Well, we can use radar, right? Radar, radio detection, and ranging is most car systems today actually use radar systems. So just on basic detection, short range is where it is the most accurate. The second you want to go long distance using radar, that's where you find yourself in trouble, right? If it's just you on an open road and all of a sudden something happens and there's something way out in the distance, you need to slow down or you need to speed up. Radar is not going to be the most accurate for that. The farther an object is away, the more unlikely it is for your car to predict that situation accurately. All right, and it's not like it's impossible. There are higher ranging radar sensors out there, and it comes down to money. It's too expensive, and its current state, it's still very unpredictable. But in short range environments, a lot of your cars already do this, and just like, oh, there's a car right next to you, there's a car in your lane, there's a car in front of you, and you stop fairly quickly. It's one of the most accurate sensors in the short range, but as soon as you want to, if you're going to use just radar in to make your own autonomous vehicle, your own autonomous car, you are going to end up with even more problems than you do with if you're just going to use LiDAR or radar right now, right? So the best case scenario going forward is, all right, each one of these has its own limitations, but each one has its own benefits. Radar is extremely precise and accurate in the short range. LiDAR can give us 3D imaging. Cameras can give us a more in-depth and a more detailed view of our environment, where LiDAR can, where radar can. So in a best case scenario, in a dream scenario where where costs come down on all of these, we can try and employ all three, where we can actually use the image data from our cameras and video data from our cameras. We can use the 3D mapping of a LiDAR sensor, and we can use the short range detection from radar to build and to make our cars that much more safer. All right. So going forward, well, we have all this image data. What about how do we actually make our cars do that? Right. And how do we make our cars like, how does it make those decisions? Right. I can give an image to you guys. You guys will be able to make a decision. Yeah, the car's got to slow down, but car doesn't know that. Right. So what I'm going to go over pretty much is just three of these and just convolutional neural networks, ResNets, and support vector machines. But what I want to ask you guys is, so these are the 5 most common neural networks that are being used, and I like bringing up Tesla. It's a very it's very in the news. So if finding something to relate this stuff to, maybe you guys can see it. But Tesla has their own neural network and their own model that they use to run. So it's not, and a lot of these autonomous vehicles, it's not just one or the other. What they do is they plug and play into a lot of these so that they can get the most accurate decision and to make the best decision possible. But I want to go through some of these, and I want to ask you guys, and this is what I wanted to highlight with you guys. I want to get your take. Why would we've already talked about convolutional neural networks. We've already talked about ResNets and SVMs to an extent, but why would we use transfer learning and or recurrent neural networks in computer vision or autonomous driving, just in general? I want to get your take.
I think transfer learning would make it less time consuming.
That's one of the big ones. What about recurrent neural networks? That feels like out of place here. Why would we even use it? Or what specifically about a recurrent neural network would we want to access?
It's the only one of these that handles time series data.
Exactly. Time series is huge, and there is. I've got a lot of papers on this, so I can post into the Discord. I think we have a papers. Do we have a papers channel? So what I'll do afterwards is there's a really good paper on recurrent neural networks. We do? All right, perfect. So there's a really good paper on using recurrent neural networks in autonomous driving and how it handles time series data going forward. But I will leave that up to your curiosity. I'll post a paper. You guys can take a look at it. It's really, really interesting stuff. And also some of the work that's being done in transfer learning. Transfer learning is really new. The current, and it's kind of on theme with what we've been talking about so far. Where are we now, and how do we keep going forward? Where am I at on time? Sweet. Cool. Then I'm almost done, actually. All right, awesome. So what I want to do is just quickly go over some of the neural networks that make this possible, and then I want you guys to kind of think of how, and especially these last 2 meetings with computer vision and now autonomous vehicles. This is more of an application of what we learned last week. So what other applications of CV do you guys see other than some of these big ones? And as you guys go through, hopefully you started your Sky's No Limit projects, but if you guys want to do something in CV, what other applications do you see of it? And based on what we talked about with perception and some of the models that are being used, where else can you see it being applied? So firstly, this is just a review of convolutional neural networks, how they work. And one of the biggest things that I want to ask you guys is why it's more of a recollection from last week. Why are we using a convolutional network as a neural network as a base? And number two, why are we not using it? Why are we not using its base architecture especially in autonomous driving? Yes, no,
I haven't answered, but I also said this last week.
go for it.
Image data big,
Right.
we need time to process, we don't have that time.
Right. Yeah, exactly. That's the biggest thing is we don't have that time, especially on the road. On the road, like that's where transfer learning is really, really big, and especially reducing the time that it takes. But this is the basis of all of our neural network models that are being used in autonomous driving and autonomous vehicles in general. What convolutional neural networks at its core allow us to do is identify details, textures, objects, obstacles that we don't really get out of any of the other models that are out there, right? So everything that we build on, and especially in the companies that are doing autonomous driving right now and anything dealing with autonomy, we start at the core is a convolutional neural network. And then from there we build up and we can build around it. So we can build up on that using ResNets. And we talked about this last week. This is pretty much a word for word slide from last week, but just to refresh your memory on why this is so big is it takes less time, and especially compared to the convolutional neural network architecture, we can eliminate the vanishing gradient problem. And like I said, we can use this in the unit, in diffusion, if you remember from like 2 weeks ago, and now here in autonomous driving as well. ResNets are extremely popular, especially when it comes to CV and to autonomous driving as well. It is one of the most popular architectures that are being used, that it's very fast, and at its core, it's still CNN, and we can build up from that. And I want to talk a little bit, and I want to spend a little bit more time. I know these two we've already really covered a lot. I really want to spend a good amount of time talking about support vector machines and why this might be really important for the field going forward. All right, so first off, what is a support vector machine? And what are its main classes or subcomponents? Anyone?
A kernel,
What about it? Give me more detail.
you wanna pass your data through a kernel, I think.
Okay. And here's what I guess here's the real question. What is it and why would we use it in this context? Got it?
I got it. The reason you want to use a support vector machine is that it, as you can see in the image there, basically the maximum separation if it is linearly separable or as close to linearly separable as possible. So it takes something like on the left, which is just any sort of linear regression. There isn't a preference for where that line would be, but the SVM is going to put the maximum separation.
Yeah, exactly. That's the biggest thing. And especially when it comes to object classification, there's a lot of research being done right now, especially where this field is headed. There's a lot to deal with support vector machines and a lot to deal with support vector support vector classification. I'll put this paper in the Google, not Google, in the Discord as well. It's a really interesting one, where in utilizing a fisheye lens system actually, and plugging that into and to support vector classification model, what they found is that comparatively to a convolutional neural network, to a ResNet, and to some of the work that they've done with recurrent neural networks, they found that support vector machines actually have the highest true positive rate when it comes to object detection, depth perception, and into the accuracy of the car's movements. As something that I found really interesting, a lot of research is being done in this space. The field of, obviously you can't, it's not just one or the other, but support vector classification, it might be the way things are headed away from a CNN into object classification, and while still using depth perception metrics from whatever perception technology that we use. So I found this really fascinating. I'll post the paper in the Discord if you guys want to read it as well. Going forward, we might see more in support vector machines. And yeah, I think it's just really interesting where this field is headed. We've come a long way just to get to level 2 autonomy within a camera, just with cameras. We know what the possible sensors are with LiDAR, radar. There are plenty of others, but these are the 2 most popular going forward. And as it comes to the models that are being used, especially with transfer learning and support vector machines, the field is headed in a to a great spot. Now the question is, can we get there efficiently? Can we get there safely? And that's, in the end of the day, that is the biggest question of them all. Yeah, so to do today's autonomous vehicles use only one of these networks? No, they use a combination of all of them. We want to get the most accurate. Each one of these has its own separate function, and we want to utilize that in order to make better decisions with our cars. It's a harmony. That's if the one thing that I want you guys to take away, especially in anything in computer vision, you can't have one without the other. You need your perception technology and you need your neural networks. They work hand in hand. You can't have one without the other. Just image data doesn't get you anything, and just a neural network won't get you anything. The field is headed in a really great spot. If you guys want to talk more about any work being done in CV, and if you guys, like I said last week, if you guys have a project in CV that you want to go over, and especially for Sky's No Limit, I'm going to keep pounding this drum. I want you guys to participate, especially with, there's going to be a lot more money this time. There's going to be a lot more people participating. If you guys want to try something new and do something in computer vision, let me know. I can definitely help you guys out going forward. But yeah, if you guys have any other questions, you guys can come up to the front, and please let us know. I'll create another feedback form for today. Please let us know what you guys thought of these kind of meetings. We're trying to make things stick. We want to know what you guys like, what you guys don't like, and trying to make it better for all you guys. So yeah, thank you guys for coming out. And yeah, thank you guys for participating too. Dope.